to find the value of to find the value of b, just substitute a equals to 2.2 in any one of the equations above. So say substituting a equals to 2.12 in equation 3, I will get b as equal to 60 minus 28 times a, which is 2.12, whole divided by 5. So that would be 0.64 in the numerator, so approximately 0.13. Therefore, the fitted line has the equation y is equal to ax plus b. Ax plus b, that is 2.12x plus 0.13. This is your final answer. I just want to discuss the next example that they have discussed in the book, which is they have asked to fit a curve y equals to ax to the power b to the data that they have given. You have got x and y data for 6 observations, but the curve that they have asked you to fit is not linear in form. It is y equals to ax to the power b. Now in a situation like this, since it's easiest to fit a linear curve, try and see if there is anything you can do to make this curve linear. And when you have an equation of this sort, the easiest way to get a linear form of this equation is to take logarithms on both sides. So taking log on both sides, I'll get it as log y is equal to log of ax b, which basically means log y is equal to log a plus b times log x. So you can write this as capital Y is equal to capital A plus capital B times, you can write this as B times capital X, where capital Y is log small y, capital A is equal to log A, and capital X is equal to log small x. Now again, let's figure out what the normal equations for this would be. So first normal equation will be by putting the summation operator to both sides of the equation. So that's summation y is equal to n times a, because summation a is a constant, so n times a, plus summation bx. So b being a constant can be taken outside the summation sign. So this is what would be your first normal equation. Your second normal equation, once again, remember it will be when you apply the summation operator to x times y. So I'll just write it in green. xy is equal to ax plus bx square. So applying the summation equation to this, I get my second normal equation, which can be written as summation capital xy is equal to a times summation x plus b times summation x square. This is the data that has been given for the question. You have small x and small y, and you have six observations each. Now remember, your normal equations are in terms of capital Y, capital X. So you need to calculate or find out what capital X is. Here, capital X is equal to log of small x. Take your calculator, perform the log operator, and you will find out log 15 is 61. Your second value will be log 20. So taking the calculator, I'm simply going to take log of 20, which is 1.3010. And so on. So I have also calculated capital Y, which is equal to log y. These are the values that you get. And remember, for my normal equations, I also need capital X square, and I need x times y. Using your calculator, you can calculate the values as, so this is your x square column, and finally x times y can be written as, so now we've got all the columns filled up and their sums found out. Just put them into your two normal equations. Your first normal equation was summation y is equal to n times a plus b times summation x in capital. So you've got 8.3215 is equal to n is 6, so 6a plus b times summation x. Summation x is 8.4983. Sorry, 8.4983 b. Similarly, your second normal equation was summation xy is equal to summation a times summation x plus b times summation x square, which can be written as 11.693 is equal to 8.4983 a plus 12.162 b. So as you can see, you have got two equations in two unknowns. Naming this equation or numbering this equation 1 and equation 2. Solve for capital B, A and small b by simultaneous equations method. So that means you can use the elimination method. So I'm going to multiply my first equation with 8.4983 and my second equation I'm going to multiply with 6. When I do this, the coefficients of A in both the transformed equations will be equal, so I can eliminate it by subtraction. So I'm naming these new equations equation 3 and 4, and now subtracting 3 minus 4, change all the signs of the second equation, and then AA cancels out. So you've got 0.562 is equal to sorry, I wrote this wrong. That'll be 50.9898A plus 72.22B. So when I subtract, I'll get 0.562 is equal to negative 0.972B. So B is equal to not 972, 0.752. So B is a negative number. It will be 0.562 divided by 0.752, which is approximately 0.747. Now substitute this into equation, any of the equations above. Let's substitute it in equation 1. So you will get putting B equals to minus 0.747 in equation 1, we will get the value of capital A as 8.3215 minus 8.49, minus 6 times 8.4983 whole divided by 6. And the value of A comes out to be approximately, I forgot, since we have to still take antilogs, so let's leave it at the value of A is 2.449. Now remember, the question asked you to fit the curve as small y is equal to A small x to the power B. So we already know the value of B, but A, since capital A is log A, small a will be antilog of capital A. Since I'm taking antilog, I have kept the capital A value up to 4 decimal points. So you can either use your logarithm tables or you can use your calculator. And the value of A comes out to be 278.6. So the curve is y is equal to 278.6 times x to the power b, which is minus 0.747.